Hello guys. So this is one plan that I have created using ChatGPT. Here in 90 days you can cover all different patterns that are there in lead code or in an DS interview. Last thing I solved was vehicle sort 2. I have to see whether I solved it or not. Oh, I solved it. It was a nice question. Yeah, we will start here sliding window 209. So today, as per this information, I am doing sliding window problems. Hello. So today I'll be doing 5 problems from lead code, and they all will be based on sliding window pattern. Let's start minimum size aberration. Given an array of positive integers. So this is an array of positive integer and a positive integer target. So target is also a positive integer. Return the minimum length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. So you have to return minimum length of a subarray, and you see these are all positive numbers. So if numbers are A, B, C, D, E, F, G, H, I, and let's say you start adding them. Let's say you take A, you take B, you take C, and now just some became greater than equal to target. Then what you have to do? You know there is a three length array or sub array whose sum is greater than or equal to target. So three can be your answer. And now there is no point going forward here. What you can do is you can start with B and find where does the sum get greater than 7. As soon as you go cross 3, there's no point going ahead because you know 3 is already the answer you have. You start with C, D, E, F. So this way, one normal solution is order n square, where you start from first A, then take the sum of the numbers, then you start from B and take the sum of the number from C, and so on. And another way could be, since you know A, B, C, it's greater than equal to 7. Now, if you take D, there is no meaning. You're just increasing the length of subarray. What you can do is you can remove A, and now you can see if BCD is greater than equal to 7. Now you are directly jumping onto the second part, second index element, and starting from here. And now if BCD is, or even better, like first you see BC. If even BC is greater than equal to 7, then Y you will take A. If not, then D you will consider. And again, if it is greater than 7, greater than, if it is going more than 3, the length of the subarray, there is no purpose going ahead. So you will remove B, and you will see if CD is greater than E, No, no. Now let's say it's greater than. So this is your answer again. If it is greater than, you will remove C and you will check the other. So this way you can find using sliding number. Longest substring without repeating characters 3. Given substringers, find the length of the longest substring without duplicate character. Okay, length of the longest substring without duplicate characters. A, not duplicate. B, C. What you can do is you can create an unordered map, and in that unordered map you can keep count of A, 1, B, 1, C, 1. Now if A comes again, you'll see key A has become 2. Okay, so there are duplicates in the array. There are going to be more duplicates in the array. Take store 3 as answer and keep on removing from front until uh, you find the same element that is currently present. So you will remove A and you will see A is now coming again. So great. This way you are ensuring that in unordered map the value of count of A remains 1. And again you keep on going like this. You see B, or let's say if there would have been C, so you will keep removing characters from here until you find C. Okay, you found C, you remove it. Now you have an array which is non-duplicated, which doesn't have duplicate characters. 424, longest repeating character replacement. रहने दो आंटी, नहीं करना नहीं करना. 424, longest repeating character replacement. You are given a stringers and an integer k. Okay, we are given a stringers AB and an integer k which is equal to 2. You can choose any character of the string. I can choose any character of the string. Okay, I can choose any character and change it to any other uppercase English character. Okay, and you can perform this operation at most k times. At most means ज़्यादा से ज़्यादा k बार कर सकते हैं ये operation. Return the length of the longest substring containing the same letter you can get after performing the above operation. So it is asking if we have A, B, and K is equal to 2, which character should I replace so that which character should I replace so that I can get maximum length substring of same character. First check what is maximum length right now. Right now if you see maximum length is A and it becomes, so it breaks again, so 1 for A, and now again B comes, but again after B there is A, so 1. So there is only two possibilities, A and B right now. Now since K is equal to 2, what we can do is you can perform this operation most K times. I perform it on B and B or A and A, and the strings becomes A or B, B, B. In the second example, I have A, double A, B, A, B, B, A, and K is 1. Here you see it's like 2A, 1B, 1A, 2B, 1A. Okay. Um, if I replace this 1B, I will have four characters which are same. Okay. We have to return the length of the longest substring. First, let's try to solve it with brute force because right now we don't have any logic. If I try to solve it through brute force, what I will do is I will start collecting letters. I'll say key it has 2A. Now there is some extra character which is coming and which is not same as previous character. So I will change this extra character and now I will make it 3A. So my max answer can be 3 and K becomes 0. So now I can only go ahead till I'm getting A. If it's not A, then I can't go ahead. So now my answer, I check the next character and the next character is again A. So now I have 4 as answer. Now I check B. Or now I see if next. Now I see that next character is B, so I can't go ahead. And K is 0 anyway. So what I have to do is I have to go back to the last character I replaced. The last character I replaced was B. And now I say, okay, since you are the last character I replaced, uh, I will carry on from you. I'll see how many characters we can make starting from you. B will say, okay, then we remove A, we get 2B. Now this A, last A, it can't be replaced with B because K is now 0. So here again we end. And again we say to B that good work, and uh, since you were the character, now let's say we can start from A instead of you. We start from A, we say A, we are trying to form best possible alliance for you. So start working. We will replace B with A and K now becomes 0. So this alliance breaks here. So there is no purpose going ahead. And now we'll say B. Okay, let's see if we can make a good alliance for you here. We will say okay. In this way, only we can make 3. So on. So this way, what we have to do is we just have to see which was the last character we changed, and as soon as K becomes 0, we go to that character and we start forming the strings for that character. Okay, so can it, in worst case, can it take like what is the square time or what time it will take, that we have to think about? Let's say case 6. Just you will go again, making characters of B, these three B, right? Or let's say case n by 2 will change n by 2 characters. Or there is a better way we can do. What if we keep count while going ahead? So here, what I'm thinking is 1A, 2A. So I'll have A, 2. Now I got B, 1B, so B, 1. So this is a new character. So what I will do is 2. Now B becomes A. I'll also keep store of total counts. Total count I anyway know which is 3. Okay. Now I got A, no issue. Now I'm getting B. One thing, since it's B, it's different from A. We can't go ahead, and now we have to move from our starting position from A to B, from this A to this B. So to do that, we have to come forward to element. If we come forward to element, A will reduce by 2. So A will become 1. B is 1. So now you have this thing in hand. Let's say that this, let's say if this was the answer. Okay, now you have two ways in forward and B is 1. And you see, since B is 1, K is 1, there can be only two elements in the list, but right now you have three. So this answer, it's not possible, right? B A string, it's not possible. So what you will do, you will remove B as well. A will become 2, A is 2 already. Now A is 2, B 0, K 1. You see that the starting element is same, and A is 2 and K is 1. We are saying starting element always, because from here, because we are making an alliance for this one. Here A is 2 because there are two elements till here, and uh, total count is 2. So and K is 0. So this is possible. Now we go ahead and include this B in our alliance as well. So B become 1, but our alliance become 3A. K is consumed now, and if we go ahead forward, we can't include this B in our alliance. Okay, so in this case, we will remove these two A. A becomes 0. There is only one B. Count is 1. K is 1. There is no issue. We include this B in our alliance. So B is 2. Nothing changed. A is there, which is different. So we count A1. There's again no need to count even. Yeah, there is a need to count. B, there are two B's inside. So you can include A as B and K is become 0. This way, you can ensure that you are done in order and time. Longest repeating character replacement. Permutation in the string. Medium. Minimum window. Substring. Permutation in string medium 567. Okay, permutation in string. Given to string S1 and S2, return true if S2 contain a permutation of S1 or false otherwise. In other words, okay, let's see the example. S2 has to contain a permutation of S1. So S2 has to contain the count what is there of characters in S1. If it's true, then we return true, otherwise we return false. This word, it looks simple. This It would have been more simple if it would have something like AB and EIDBA. Oh, oh. AB का permutation BA it exists. It's not like कि अगर A यहाँ पे है and this is a permutation. No, they're looking for uh, some continuous substring in this part, which is permutation of this one, of string S1. So what we can do is we can count characters here. A is 1 and B is 1. Okay, A is 1 and B is 1. Now let's say if we start from here and we see E and we check if E is there, E is not even there, so there's no purpose taking E. I is not there, no purpose taking I. D is not there. We create a hash map of this S1 so we can directly check in order one time. And as soon as we check B, we see B is there. Okay, now we check for O. O is not there. O is not there, then what we will do is we will remove the count of everything from this one because there is one character which is out of the S1. We say A, O A is there. and A is one time and one time or is there. Now let's say here, okay, we got AB, and the size of this one, size of it. So we are 20 here. Let's take some complicated string. By complicated, I mean B, C, B, A, D, E. So A1, B2, C1, D1, E1, F2. Okay. Now let's say F A C D B A C C D E F B F C B D E. Okay. Let's say this is the correct string we are taking. We came, we say Visaki F1 is the A1, then F became 2, which is okay because it is in line. A became 1, now A became 2. As soon as A became 2, we are ahead of the string. So what we'll do is we will remove the character from start until 1A is removed. So we'll remove 1A, 1F. So this is the thing we are focusing now. Now we came to C, C1, okay. Now we come to D. D is also allowed one time. We again came to C. C became two times. As soon as C became two times, we see C is only allowed one time. So we'll remove the character FAC from here. F became 0, A became 0, C became 1. So now we only have CD. Okay, we forward to write B1. Okay, we have DBC. Now D came. D will become two times, so we can't allow that. So we'll remove until we find D. So D is removed. D became 0, and new D is included. So this D became 1 again. So DCD. Now our focus is on E. E is also allowed one time. So E one time, no issue. F F is allowed two times. So F became one time. This is the thing we are focusing on. Now B. B became two time. B is two time allowed, no issue. So keep saying that our string is now 6 character long, and what we need here is 8 character long. We see F is allowed two times, no issue. So F become two times, and F is included. Our string is still 7 character long, not more. Or it has to be 8 character long for the answer. We see C. you see, we are missing A right now. If there would have been any A, okay, yeah, this is not the answer. You can get it right. Now let's say we include C. C become two times, which is not allowed. So we have to remove characters B and C from here. Now C and B C we remove. So one C we added. So we only remove one B now. So this is six character long, and there are six count here. B D A. If we add B, B become two times, which is allowed. If we add D, D become two times, which is not allowed because D is only one time here. So we'll remove this D and this D is added. So it's okay now. Now we add one A. If we add one A is allowed here. This became 8 character long. This one is 8 character long. Our answer is done. This is the solution for permutation in substring. Minimum window substring 76. Given two string S and T of length M and S and T of length M and N respectively, return the minimum window substring of S. Minimum window substring. Substring means continuous minimum. We know minimum. By window, it's asking for the characters as well. Such that every character in T, including duplicates, is included in the window. Here, let's say T is double A B C. So this S it has to contain a window which has 2A and BC. This is similar to the last one. We keep checking, and as soon we keep adding characters, we keep adding characters. As long as we don't find, okay, let's say we took A. This was ABC only. If you see ABC both all reached, but how will you know that uh, you have reached, you have added all what is there? What you will have to do is, you see, there are three distinct chars. So three hash in your map, and since there are three hash in your map, you will count. You have to count when these three hash become less than zero. Once they do, you got your answer. Now all you can try is, can I get better answer than current string. Okay, let's say current string. So for that, you will keep on removing elements. As soon as you remove a, your hash map here, again a became 1, a was 0 initially, b is still 0, and c is still 0. Others you don't track because they don't matter. And now you see d, it's not even there. But the string you are seeing right now is not your answer, become because just as soon as a became 1, your count of positive hash increased by 1 from 0. So you are not at any answer substring. Then you can remove d. It doesn't matter because d is not in this map. You can remove o. It doesn't matter. B, it is there. It is 0. It's not even -1, so you can't remove b, because if you remove b, this will become 1 and you will be far away from your answer. So b, c is there. And let's say if you get a by chance here, this a will again become 0. Your count of positive hash will go from 1 to 0. You are at an answer b, c, a. This way you can count minimum window substring. Okay, thank you.